Hello everyone. In this class we are going to discuss one of the important topic, like students are scared of this one. Okay. One of the important topic means this here word problems on maxima minima. We have learned maxima minima for like simple functions. Algebraic functions are there, trigonometric functions are there. We have learned how to find the maximum or minimum value of them. Now we are going to discuss the word problems, or you can say practical problems from the maxima minima topic. Like some figures are there, then the figures volume should be maximum, then what will be the condition, and so on. Okay, so these are the word problems. Students are like scared of doing this one. Why? Because there are different methods from different sources. Like if you are doing from book, different methods are there. If you are doing from the net or any teachers or any other sources, so like different methods are there for doing this one. Okay, that's why students are get puzzled for doing, like when actual problem comes they are got puzzled. Okay, so we are going to discuss like one common method that is applicable for all types of word problems based on maxima and minima. Common method, and along with this common method we will discuss some tricks also on, like when we are doing questions at some of the steps we will apply some tricks so that there will be minimum time you will require to do this question. Okay, let's start the word problems, the common method you can say. The first thing, from the question, when you see the question, the three things you have to find out first. Three important things. First, what is given in the question. The second one, the function to be maximized or minimized. Maximized or minimized. Okay, because this is the most important portion of these 3 points here. And then to find or to prove. If you can get these 3 points properly, your half of the problems will be solved automatically, and the rest 50% depends upon your like differentiation concept and simplification. Okay, let's see here these 3 points. Once we got it, and then you will realize this function to be maximized or minimized. This function is present in more than one variable. Is present in more than one variable. Mostly it is present in two variables. Mostly two variables. Here two variables. Okay, now mostly it is present in two variables. This two variables, this function which is present in two variables, first you have to convert it into a single variable function. Then single variable function. And how you are going to convert this into a single variable function? From the given data here. Whatever the given data is there, you have to use that one to convert this two variable function into a single variable function. This is the primary function you have to do. Primary work you have to do, like converting the more than one variable function into a single variable function. Then we will apply the maxima minima process, like differentiating, putting it 0, finding the value of x, and so on. Okay, we will apply the maxima minima process after this, after converting the function into a single variable function. Now to find, or here to prove, you can write to find or you can write to prove, because something you have to prove also, or sometimes the question being asked like to find this and this. Okay, so this single variable function that you are finding, it must be present in terms of what you have to find. Suppose a function that you got is present in two variables, x square and y square. Suppose like this. Okay, now you have to convert this two variable function into a single variable function, either in x or in y. How we are going to convert it? Using the given data. Something will be given, like sum of the two numbers is 20. Then find the value of y, put it here, or find the value of x, put it here. It will be converted into a single variable function. Okay, now this, after converting this one into a single variable function, this single variable must be present here. What you have to find actually here, if you have to find the numbers, this must be in either x or in y. Okay, That's all. This is what the process actually is. Okay, 3 things you have to find first. Function to be maximized or minimized must be present in mostly 2 variables. Convert into a single variable using the given data, and then prove it that the function will be maximum or minimum, like our process of maxima and minima. Okay, let's see some questions based on this. What problems then? Here the question says, so that the right circular cylinder of the given total surface area and maximum volume is such that height is equals to the diameter of its base. What I said, whatever the question is, let's find out the 3 things first. What is given here? Function to be maximized or minimized. Function to be maximized or minimized. Here you have to maximize the volume here. So here it should be maximized. Okay. If it is of like find the least volume and so on, you have to minimize the function then. Okay. And here you have to prove something. Its height is equals to the some like diameter of the base. That means you have to prove something. Okay. So let's find out these 3 things here. First, what is given? Here, show that a right circular cylinder of given total surface area. It means what? The given portion is, or given data is our TSA, total surface area of this cylinder. Let's take this total surface area as S. Okay, so this S is given and it will be treated as a constant. It will be treated as a constant throughout its differentiation. Okay, now function to be maximized here, as you can see from the question, and maximum volume. That means you have to maximize its volume. Okay, this volume you have to maximize. And what is the max volume formula for a cylinder? We know it is pi r square h. Okay, this pi r square h you have to maximize. And what you have to prove here is such that height is equals to the diameter of its base. We have to prove h is equals to diameter. Diameter is nothing but twice of the radius. That's why I have written h and r. Now here if you can see, this is the function to be maximized, and I said it must be present in, like mostly it will be present in more than 1 variable. As you can see, 2 variables are present, both r and h, 2 variables are present. Okay, now we have to convert this into a single variable, either in h or in r. And what you have to prove? H you have to prove. H is equal to 2r you have to prove. That means you need to find h here. Okay, now let's convert this one into a single variable first. From where we will convert? From the given data. Here S is given, this one is given, and S of, that is the total surface area of right circular cylinder. What we know? This one is 2 pi RH plus 2 pi r square. This is the formula for the total surface area of a cylinder. From here we can find the value of h. Simply you can get the value of h from here, because getting the value of r is difficult, because here r present in quadratic equation and you have to follow the quadratic formula and then you will get the value of r. So instead of getting the value of r, it's easier to get the value of h. So let's find out the value of h. From here it will be s minus 2 pi r square. It is 2 pi r h, and h will be equals to this s minus 2 pi r square divided by 2 pi r. So this is the value of h we got. Now let's put it in our function. This is the function and we have to maximize this function. So let's see, v equals to pi r square h here. Okay, let's put the value of h here, pi r square, and the value of h we know already. We will put it here, s minus 2 pi r square divided by 2 pi r. So this is the function we got, and as you can see, this function is present in terms of r only. That is one variable. S is a constant because it is given and it will be treated as a constant always. Now let's simplify this one a bit. This pi cancel, 1 r and 1 r will be cancelled. You will get r by 2 of s minus 2 pi r square, or it will be s r by 2 minus 2 cancel, you will get pi r cube. So this is the function we got. This is the function in r we got, and this is the most important portion. after getting the function, you have to maximize this one, and we know how to maximize any function. There is a process. So let's take this function, and it will be used afterwards also. Now let's take the function and maximize it. We have to prove h is equals to 2r at last. Now see, our function f of r is equals to sr by 2 minus pi r cube. Now we know how to maximize this function. Let's find out the differentiation first. It will be s by 2 minus 3 pi r square. After differentiating, we got this one. After differentiating, what is the next step? Putting it 0 and getting the value of r here. Okay, so s by 2 minus 3 pi r square equals to 0, or s is equals to 6 pi r square you will get. Okay, after simplification you will get this one. From here we will get the value of r as s by 6 pi under root, because r square was there and we are ignoring the negative sign. Why? Radius cannot be negative. That's why we are ignoring the negative sign, only positive value we are getting. Now this is the value of r we got. Okay, this is the value of r we got. Now after getting the value of r, we have to prove this value of r is our point of maxima. So what we will use? First derivative test. Okay, first derivative test. Now what we will do is, now this is one of the trick I am explaining now. Listen carefully. Here this one has to be point of maxima actually, because the question says maximum volume. Okay, so maximum volume means volume has to be maximum, and if volume has to be maximum, this r must be the point of maxima, otherwise the question will not be solved. That's why we have concluded what? This r has to be point of maxima anyhow, by anyhow. It has to be. So we are not checking anything. We will prove this one point of maxima directly. Directly how? If we are using the first derivative test, then this is r is equals to root over s by 6 pi we can write, and r cannot be minus negative, so r to infinity we can take. Okay, and what is the condition of point of maxima? The sign of f dash r, the sign of f dash r must be from positive to negative. Without calculating the actual sign of f dash r, before this r is equals to 6s by 6 pi root, before this interval and after this interval, we are not going to check the sign of f dash r. We will directly put f dash r will be greater than 0, less than 0. Why? Because this one has to be point of maxima, has to be. That's why we can put it like this directly without checking anything. Then r is equals to root over s by 6 pi is the point of maxima we will write. And if it is point of maxima, our f of r will be maximum, will attain its maximum value, at r is equals to root over s by 6 pi. So we have maximized the volume here. Directly, like indirectly, we have maximized the volume. Now we have to prove h is equals to 2r. How we are going to prove it? Let's see. So this one here, h is equals to s minus 2 pi r square divided by 2 pi r was there. So the second trick I am using it now. The second trick is what? Instead of putting the value of r here, instead of putting the value of r and getting the value of h, what I am doing is we are putting the value of s directly and you will get the answer directly. Most students are doing what? R value we got. After putting the value of r, we can get the value of h in terms of s. Okay, after putting the value of r, we can get the value of h. Then they are doing h by r and it will becomes equals to 2. It will come as equals to 2. That will, like, it will be a long process and it will consume time also. So instead of putting the value of r, we will put the value of its previous step. What is its previous step? S is equal to 6 pi r square. We will put it here. What will happen? H is equals to, S means 6 pi r square. Let's put it 6 pi r square minus 2 pi r square divided by 2 pi r is present. Okay, now let's see after simplification what we are getting here. After simplification, h will be equals to 6 pi minus 2 pi r square will give you 4 pi r square divided by 2 pi r is there. This pi and pi cancel 1 r. So what you are getting? H equals to 2r, and that's what you have to prove. Only 2 steps it took to prove h is equals to 2r. And if you are putting the value of r to get the value of h, it will take at least half page. Okay, so it will save your time. So 2 tricks I have taken. The first one, this one has to be point of maxima. So we have not checked the actual sign of f dash r at different intervals. We have directly put it as point of maxima. Okay, the second trick, what is there? Instead of putting the value of r, we have taken the s value here to prove it. Okay, that's how you will take a minimum time to get or to do these type of questions. I hope it's clear. Now let's see some more questions based on the same concept. Let's see. So let's see another question based on the same topic here. Show that the right circular cone of least curved surface area. Okay, before starting the question, let's write down the 3 things that I've said. What is given here? Function to be maximized or minimized. Here, what you have to do? You have to least curved surface area, maximum, least, or whenever these terms are used, that will indicate whether you have to maximize the function or minimize it. Here least means you have to minimize the function. Okay, minimize the function. Then next, what you have to prove actually, or what you have to find. Here you have to prove something. What you have to prove? Altitude is equal to √2 times the radius of the base. Okay, this is what you have to prove. Now let's see one by one from the question. What is there? Show that the right circular cone of least curved surface area and given volume. That means what is given here? Volume is given. What is given? Volume is given. Let's suppose this one as V. Function to be minimized here. What you have to minimize? Least curved surface area. Means you have to minimize this curved surface area. Okay. What is the curved surface area of a right circular cone? It is nothing but pi r L, where L is the slant height. Okay. Now to prove, what you have to prove? Altitude h is equals to √2 r. Altitude is equals to √2 times the radius of the base. That means h is equals to √2 r. You have to prove here. Okay. So this is, we have summarized here. Now let's see whether the function is it present in one variable or two variable function. As you can see, there is two variable function present. The function present in two variable function, we have to convert it into a single variable. From where? From the given data. Okay, so this V is given. What is the V of a right circular cone? It is nothing but 1/3 pi r square h. Okay, now here this one we are leaving it now, just for now. Let's see here the function. Our function is CSA is equals to pi r L, where L is the slant height, but here there is a conversion of r into h is given, means you have to convert this function in r and h only, so that you will convert one variable into another. So we will convert this L as √h square plus r square. H square plus r square, where slant height. If you know the diagram of a cone, it looks like this one, and this slant height L, the radius r and h forming a right angle triangle, applying the Pythagoras theorem, you will get this one. I hope it's clear. Okay, so this is our CSA. Suppose this one is C. Now as you can see, this is our function present in two variables, and these two variables square root is present. So we will use another trick here. What is the trick? Here, if square root is present somewhere in the function, differentiating this one is little bit difficult. Okay, if we can convert this one into a simple polynomial function, then differentiating this one will be quite easier. Okay, so we are eliminating the square root from here and we are converting into a single polynomial, simple polynomial. Then how we are going to convert it? What we will do, if you do the squaring both side here, we will get, but the problem is here the function becomes also squaring. Square of the function we are getting h square plus r square on squaring. on squaring both side. Okay, on squaring both side we are getting this one. Now what you have to write it here is when c is minimum, we have to minimize the function. So what we will write, one statement you have to write here, when c is minimum, c square will also be minimum, So our new function, this is our original function. After squaring both sides, we got this function now, and this one, as you can see, there is no square root term is involved, and we can take this one as our new function. Suppose this is capital C, suppose, okay, we will change it afterwards. Suppose this is capital C, okay, c square will become your capital C, and this is our new function. Why I have squaring both sides? Because root term was there and we have to eliminate this root term, because it will create problems on differentiation. So we have squaring both sides, and what is the statement I've written? When c is minimum, c square will also be minimum. So we have to find the minimum value of this c, and this will give you the same minimum value if you are doing c square also. Okay, if c will give minimum, c square will also give the minimum value then. Okay, this is what we can do to avoid the root terms present here. To avoid the root terms present here, we can use the squaring both sides or cubing both sides according to the question. Okay, the reason you have to write this one simple. Now this function, as you can see, this pi r square h square plus r square, this one is present in two variable function. Okay, now finding the r square is easier than finding the value of h. You can take the value of h also and put it here, then r to the power 4 term will come up. Okay, r to the power 4 term will come up, and then you have to simplify a little bit, time consuming thing. So instead of taking out the value of h from here and putting it there, we are finding the value of r square now. If you are getting the value of r square, it will be 3v divided by pi h. So this is the value of r square we are getting. Okay, r square. Now let's put it here. Then the equation will be in quadratic form. But if you are finding the value of h in terms of r and putting it there, you will get a term of r to the power 4. That is, simplification of that one is little bit difficult. Okay, so we are taking the value of r square. Let's put it here. Okay, now see the value of capital C. The value of capital C will be, so here the value of capital C will be equals to, here the equation was pi r square of h square plus r square. So let's put it, the value of r square we will put here, it will be pi into 3v divided by pi h. V will be treated as a constant because it is already given. So h square plus r square, again we can write as 3v divided by pi h. Okay, now you can see the function is simple, polynomial function is given. Okay, now this one function present in terms of r h, so we will take this function as f of h. Now let's simplify a little bit. Pi, and then if you multiply 3v divided by h into h square plus 3v divided by h into 3v divided by pi h. This is what we are getting, f of h, or this one is 3vh. Cancel out here, this nothing is cancelled, so it will be 9v square divided by pi h square you will get. Okay, so this is the value of our function f of h, and this is, you have to minimize this function here. Okay, now how to minimize? We know the process. Differentiating it first. Let's differentiate it. So let's differentiate this one. Here f dash h will be what? Let's see. Differentiating 3vh, you will get only 3v. Okay, now 9v square by pi h square. 9v square divided by pi is a constant. Differentiation of 1 by h square. If you know the differentiation of 1 by h square, ddh of 1 by h square, we can write 1 by h square as h to the power minus 2, and it will give minus 2 h to the power minus 3. Or we can write this one as minus 2 by h cube. Here we can write. Okay, let's write it into minus 2 by h cube you are getting here after differentiating 1 by h square. Now this one we got. So 3v minus 18v square divided by pi h cube. So this is the value of f of h we got. Now the next step, putting f dash h equals to 0 and getting the value of h, and that h will be the point of minima. Okay, let's find out this value of h here. So it will be, if you put f dash h equals to 0 here, f dash h is equal to 0, it means what? 3v minus 18v square divided by pi h cube equals to 0. We have put it here. Now let's find out the value of h from here. It will be 18v square divided by pi h cube equals to 3v here. Okay, so if you are finding the value of h cube, it will be 18v square divided by pi into 3v we can write. Okay, now v and v cancel, 3 6 are, so h cube is equals to 6v divided by pi. 6v divided by pi we are getting, or what we can write this one as, implies that v is equals to pi h cube divided by 6 we can write, or h value if you are finding from here, h value, it will be 6v divided by pi whole to the power 1/3. So this is the value of h we got here. This is the value of h we got here. Now this value of h has to be point of minima. Why? Because you have to minimize the curved surface area. So instead of calculating anything, first derivative test we will write like this, and then we will put it, this h is equal to 6v divided by pi whole to the power 1/3 and 0 to infinity. Now h is equal to 6v divided by pi, and this one has to be point of minima. So what we will write? The condition for the minima, f dash h must be less than 0 first and then greater than 0. Less than, then greater than, then it will be called as point of minima. Okay, so h is equals to 6v divided by pi whole to the power 1/3 is the point of minima. Is the point of minima we can write. And f of h. Now let's talk about the f of h. That is our curved surface area. That is, f of h is attaining or attains minimum value at h is equal to 6v divided by pi whole to the power 1/3. See, this one we have taken directly. We are not calculating anything. We have proved this h is equal to this one is the point of minima. So our function will be minimum. That's it. Okay, we have proved the first part. Now what you have to actually prove? H is equals to √2r. Okay, we will use this one to prove it. Let's see. Here, if you see, instead of putting the value of h here and making the whole calculation, it will be time consuming. So what I said, we have to put the previous step of this one. Instead of putting the value of h, we will put the value of v here. What will happen? Let's see. R square, this one, r square is equals to 3v divided by ph is there, pi h is there, and v value, v is what? Pi h cube divided by 6. This is the value of v. If you like simplify this one, h square 3 to the 6. So what we are getting actually here? We are getting r square is equals to h square by 2, or h square is equals to 2r square. Now h will be equals to √2r square, plus minus we are not taking because height cannot be negative. So √2r square will become your r, and this is h is equals to √2r. That's what you have to prove it. See, this one is the whole process is little bit like we are taking less time than we are doing it before. Okay, now we are taking less time now because we have used this trick first and instead of putting the value of r square, instead of putting the value of h here, we are putting the value of v, and we are getting the answer in very short time. That's how we will do. Okay, the same concept we are applying here also. Given what is given, function to be maximized or minimized, and what you have to prove. That's how we can do. And the one more tip we have used. What is the trick that we used? There c was coming in terms of root. Our function was coming in terms of root, so we have squared both sides. Squaring both sides we have used to eliminate this root term, and we got c square into a simple polynomial function. And this c square we have taken as another function. That's how we can do. So these are the small trick you can use to do these word problems on Maxima Minima question. I hope it's clear. Let's see last question of this lecture, then we will finish up, or we will wind up the class then. Okay, let's see the last question then. Okay, let's see the last question of this lecture then. Show that the semi-vertical angle of the cone of maximum volume and of given slant height. So let's find out these 3 points first. Given and function to be maximized or minimized. Function to be maximized here, because you have to find the maximum volume here. Function to be maximized, and what you have to find, or what you have to prove here actually. What you have to prove here? The semi-vertical angle. What is the semi-vertical angle then? If you see the cone here, this is the cone shape, and this is the vertical line, this is the horizontal line, as you can see. Now the whole angle from here to here, is called a vertical angle. Now if you make it half, it becomes semi-vertical angle. So let's take this one, this angle only from here to here, this angle is alpha. Alpha is semi-vertical angle. Okay, this alpha is semi-vertical angle. Now if you see the cone here, this one is considered as height, this one as radius, and this one, the slant portion, is nothing but your slant height. This is what we know. Okay, we will come to this one afterwards. Let's see what is given here. What is given here? Slant height is given. Okay, slant height is given. Let's take this slant height as L. Function to be maximized here. What you have to maximize here? Volume you have to maximize, as you can see from the question. So here we have to maximize the volume. Volume of a cone is what? It is nothing but 1/3 pi r square h. Done. Now what you have to prove? The semi-vertical angle you have to prove is equals to tan inverse of root 2. That is, this alpha is equals to tan inverse of root 2. This is what you have to prove it. Okay, means you have to find the value of alpha, not height, not slant height, not radius, not at all. We have to find the value of alpha here. Okay, alpha. So means we have to convert this volume function in terms of alpha only, so that we can find the point of maxima here in terms of alpha. Okay, now let's see. The slant height is given L. L is equals to what we know, root over h square plus r square from the cone shape. So L square will be h square plus r square. Let's keep it here. We will find out accordingly. Now volume function. This is what you have to maximize here. 1/3 pi r square h is present. Now let's convert this r square from here, because finding the value of h, it will again in terms of root, and differentiating root term, it's very difficult. So let's find out the value of r and put it here, this r square. So our v will be 1/3 pi r square. If you are finding from here, it will be L square minus h square. This one, pi L square minus h square into h. Okay, so 1/3 pi L square h minus h cube. So this is what you are getting our function, but it is not over yet. The function is converted into a single variable function, that is in h, but you have to convert this one in terms of what you have to find. That means in terms of alpha. The previous question that we have done, what we have to find was actually present in the function after converting into a single variable function. But here, after converting into single variable function, this v is not in terms of alpha. It means what? You have to convert it in terms of alpha first. Okay. Now how we are going to convert it? Let's see from the figure. If you can see, this is our right angle triangle being formed. If you are finding the value of cos alpha from here, suppose cos alpha. Okay. Cos alpha, this value of alpha. Alpha means, cos alpha means base by hypotenuse. Our base is h, hypotenuse is L. So what we are getting, h is equals to L cos alpha we got. Okay. Now if you are finding the value of sin alpha from here, sin alpha is what? Perpendicular by hypotenuse, and for this angle perpendicular is r divided by h. So r will be h sin alpha. So h and r value we got actually. Now but we need only one value, that is we need only h value. Okay. Now what we did, we have converted into single variable function. There is alternative method of this one also. What is the alternative method? Instead of converting into a single variable function, you can put the value of r and the value of h from these two. If you can put the value of r and h here, it will automatically convert it in terms of alpha. Okay. So either you convert this one into a alpha function by putting the value of r and h from here. You can put it, you will get the value of alpha. Or you can do in this way also. Both will give you the same answer. Okay. Now let's see, this one is pi by 3. Our L is a constant. H value we can get from here L cos alpha. Let's put it. Minus again h value is L cos alpha whole cube, which will turn into L cube cos cube alpha. I hope it's clear. Now let's see our function. Our function becomes, here v is equals to pi by 3, v equals to pi by 3, and here L square into L will give you L cube cos alpha minus L cube cos cube alpha. So this is what we are getting. So it will be pi L cube divided by 3 cos alpha minus cos cube alpha. So this is our function, and you can see this one present solely in terms of alpha. Okay, only alpha is present, so this is the function present in alpha. L is a constant, it will be treated as a constant. Okay, now we have to maximize this function. Now we have to maximize this function, and we know how to maximize any function. We have to differentiate this one first. Let's find out the differentiation here. It will be pi L cube by 3 is a constant, it will be treated as a constant. Cos alpha differentiation is minus sin alpha minus cos cube alpha differentiation. If you learn the chain rule of the differentiation, you can write this one. The differentiation of cos cube alpha is 3 cos square alpha into minus sin alpha, differentiation of the cos alpha then. Okay, so this one pi L cube by 3, and here minus sin alpha, minus and minus becomes plus 3 sin alpha cos square alpha. So this is the function we are getting after differentiating this one. Next step, putting f dash alpha equals to 0 and getting the value of alpha. Let's find out. Let's follow the next step then, putting f dash alpha equals to 0 and getting the value of alpha. Okay, f dash alpha equals to 0. Let's see, f dash alpha is what? Pi L cube divided by 3 minus sin alpha plus 3 sin alpha cos square alpha. Okay, this one equals to 0. Pi L cube by 3 when it goes on the right side becomes 0 because L cannot be 0. So it will be minus sin alpha plus 3 sin alpha cos square alpha equals to 0. After simplifying, keeping the sin alpha as a, you can take it common. Okay, let's take it common. Sin alpha is a common, it will be minus 1 plus 3 cos square alpha equals to 0. So this is what we are getting now. Now let's see the value of alpha. What are the values of alpha we are getting here? There are two factors present. First one is either sin alpha will be 0, either sin alpha will be 0. Either sin alpha will be 0, that will give you alpha is equals to 0 degree. Tan 0 is 0 degree. Now, if you can think, if alpha becomes 0 degree, that is, this slant portion becomes your vertical portion now. Slant portion of this cone becomes your vertical now, and when it becomes your vertical portion, it will no longer be a cone then. Okay, that means alpha must be, it will be less, but still some angle, some semi-vertical angle must be there. Otherwise, this will become a straight line. It will no longer be a cone then. It means what? Alpha is equals to 0 degree is not possible, because if it becomes 0 degree, cone will not exist. It will become a straight line. Now, the second factor, -1 plus 3 cos square alpha equals to 0 degree, and from here you will get 3 cos square alpha is equals to 1, and cos alpha is equals to 1 by root 3, or cos square alpha is equals to 1 by 3, or cos alpha is equals to 1 by root 3 you are getting. So this is the value of alpha. Alpha will be cos inverse of 1 by root 3. So this is the value of alpha we got. Let's write it. Alpha is equals to cos inverse of 1 by root 3. Okay. So this one has to be point of maxima according to the question. Okay. You have to show it like this one is the point of maxima first. Okay. So means to show it, what we usually do, writing first derivative test here, first derivative test, and then alpha will be from more than 0 up to infinity. Alpha is equal to cos inverse of 1 by root 3, and then up to infinity. Now alpha is equal to cos inverse of 1 by root 3, and here this one has to be point of maxima. So what we will write? Alpha greater than 0, less than 0. That's it. You can check also. It will become as greater than 0, less than also. So what we will then? Alpha will be cos inverse of 1 by root 3 is the point of maxima we can write. And if it is point of maxima, f of alpha will attains its maximum value at alpha is equals to cos inverse of 1 by root 3. So this is the value of alpha we got. But what you have to prove? Alpha is equals to tan inverse of root 2. Alpha equals to tan inverse of root 2 means alpha that you found out which is present in cos inverse, you have to convert this cos inverse into tan inverse first. Then only our answer will be verified according to the question. So as if you know the process how to convert inverse trigonometric function you learnt in inverse trigonometric function chapter, we can convert this cos inverse of 1 by root 3 into tan inverse using this process. So alpha is equals to cos inverse of 1 by root 3 is present, 1 by root 3. Then cos alpha will be 1 by root 3. Okay. Then this one is b by h, but base by hypotenuse. Base is 1, hypotenuse root 3. What will be the value of p then? It will be h square minus b square, that is root 3 whole square minus 1 whole square, which will give you 3 minus 1, that is root 2 you will get. Okay. Ultimately the value of p you are getting as root 2. Now cos alpha is 1 by root 3 b by h. If you are finding tan alpha, then what will happen? Perpendicular by hypotenuse. Perpendicular is root 2. Hypotenuse is this one will be 1 by b by h. It will be perpendicular by base. It is this one tan alpha is nothing but perpendicular by base. So perpendicular is root 2 and base is 1. So tan alpha we are getting as root 2. So what will be the value of alpha then? Tan inverse of root 2. And this alpha is nothing but your point of maxima also, and we are getting the maximum value of the function f of alpha then. And this is what you have to prove. When alpha is this one, you will get the maximum value of the function. That's all. That's it. This is how we are going to do. When after converting the function, still you are not getting what you have to find there. Because after converting, we got the equation in h. But we don't have to find h. We have to convert it in terms of alpha. And as you can see from the figure, we can convert it. Okay. That's how we are going to do all the word problems based on the maxima minima as Like 3 things you have to find out first, and as we discussed. Okay, so that's all for today. Thank you.